So we are discussing post drift studies. Before this we discussed continental drift. Now I can use the word theory. Continental drift theory. See, first we studied this, then we came here. After this, geologist, oceanographers, in this we studied convection current theory. Here sea flow spreading. Okay. Timeline, all of you know. Okay. 1915, then 1930, then in 1960. So after this, all the ideas, see, all the ideas from here and here were combined. All the previous ideas were all combined into a new theory called Plate Tectonics Theory. Plate Tectonics Theory. It's a comprehensive theory. Comprehensive means it combines all the previous ideas. Okay, it comprises all the ideas from the past and combines it into one theory called Plate Tectonics Theory. It came in 1967-68 by Mackenzie, Parker and Morgan. Mackenzie, Parker and Morgan. Mackenzie, Parker and Morgan, 1967-68. They combined all the previous ideas into new theory. So why am I showing you that flow? Because you should know which came after which. Okay. So that means plate tectonics is also part of post drift. You have to understand that. Okay, one of the outcome of post drift study is plate tectonics theory. Okay. So what is plate? All of you know. Plate is nothing but the lithosphere. Portions of lithosphere is called as plate. And the movement of plate and the resulting consequence is called as tectonics. Please write. Plates are nothing but lithosphere, outermost hard shell of the earth. Other word for lithosphere itself is plates now. Okay. Only thing is lithosphere is a continuous slab, outer slab. The broken portions are called as plates. Okay. The broken portions of lithosphere are called as plates. Outermost hard shell. Outermost hard shell of the earth is lithosphere. Where is lithosphere or plate located? Above asthenosphere. Right. Located above asthenosphere. Above asthenosphere. What does this lithosphere consist of? Crust and uppermost mantle. Do you all agree? Crust and uppermost mantle. Uppermost mantle. If you are unable to understand this, go to the diagram. V-shaped diagram we wrote, remember? Like ice cream cone, we wrote one diagram. Go to that diagram. There you can see crust. Below that you will see upper mantle. A I have written. A. Lithosphere, asthenosphere. That part. In that diagram, quickly notice that. Around few pages back. Notice A. A, this one. This I called A. No, not just capital A, small a. Small a. This crust and this part. Small letter A. The crust is continental crust, oceanic crust. Below that we have that A part, that is called as lithosphere. Below lithosphere is asthenosphere. Yes, don't forget. Is it clear now? What is lithosphere? All of you know. The broken portion of lithosphere is called as plates. The broken portions of the lithosphere are called as plates. Okay, I'll tell you one simple analogy. I'll tell you. Let's say lithosphere is like glass. Correct? Just like how lithosphere is, just like how glass is very fragile, delicate, lithosphere is also very fragile. This outer part I am talking about. This outer part is like a glass slab. Okay, please notice this. Just like how glass is very delicate, this is also very delicate. So what happens if you throw stones on the glass? It will break. Asteroids. What happens when the asteroids come and fall? It will break. What happens when there is earthquake? It will cause damage. Volcanoes cause damage. What happens if we explode nuclear bomb? It will damage. You got it? So just like if you drop the glass, it will break. Our lithosphere is also broken into small pieces. And all of them are moving now. Correct. That movement of plates and the resulting consequence is called as tectonics. Please write. Movement of plates and resulting consequence is called as tectonics. The movement of plates and the resulting consequence is called as tectonics. Just like you say the flow of charges or electrons and the resulting consequence is electronics. Correct. Everything what an electron does is called as electronics. Just like that, the movement of plate and the resulting consequence is called as tectonics. That means everything that is happening on the Earth's surface, whether it's a mountain formation or an earthquake or a volcano or a trench formation, everything comes under the word tectonics now. Okay? Tectonics. Movement of plate and the resulting consequence. This was done by these authors, Mackenzie, Parker and Morgan. Now, right. Types of plates. Types of tectonic plates. We can classify tectonic plates into two types, based on structure and based on size also. Types of plates, structure and size. So first one is structure, we'll discuss. That means plates can be classified based on the size and structure. So please notice this. The continental crust, all of you know. Continental crust is made up of CC, continental crust. Below the continental crust is a denser crust called SIMA. All of you know this. SIMA. This is the crust. Below this is the uppermost mantle, A. Uppermost mantle. Uppermost mantle. This is what you saw in the diagram video. We saw a plate going down. This the diagram. So now glaciers are melting. Many rivers are flowing into the ocean. Correct. Rainwater. All this water will fall on the earth's surface here. Water falling on the mountain, where it will go? Either this side or this side. Finally, it will go and settle here. Correct. All the water will form here. Since majority of the crust, this crust is under the water, it is called as oceanic crust. So this crust is also called as oceanic crust. The denser crust is oceanic crust here. Continental crust is Sial. It is not that dense. This is denser. Clear to all? Continental crust, oceanic crust. And then mantle. If the plate, let's say I'll divide this into two parts, that and this. In this you notice we have more continental crust visible on the surface. So it is called as continental plate. Continental plate. Here there is no continent visible to us, only oceanic. So oceanic plate. Oceanic plate. So based on the structure, we have two types. Based on the structure, two types: continental plate, oceanic plate. Please write first. Continental plate, oceanic plate. Clear to all? Draw first. Next is size. We need more space for that. Size. Based on size, we have divided plate into three types: major, minor, micro. Okay. Can I go to the next page? Alright, right. This is also same, uppermost mantle. Okay. A. So oceanic plate, continental plate. In your atlas, I'll tell you the page number. If you are done writing, go to page number 118, 118. Oh, sorry. Take this. 118. 118. No, it's okay. Leave it. Don't worry. Concentrate on your topic. 118. Page number 117 or 118. In other atlas, 119. Yes, Oxford Atlas. All of you got it? Notice the map and the boundary, please. Based on size, please notice major, minor and micro, three types. All those plates which are more than 20 million square kilometers, 20 million square kilometers in area is called as major. More than this, 20 million to 1 million square kilometers is called as minor. Less than 1 million square kilometers is micro. Okay, please remember three types. I'll mention the names. What you do is you see the atlas first. Okay, major plates are, first one, I want you to see Eurasian plate. Eurasian, check the map, locate Eurasian, mark. First one is Eurasian. All of you look at it, Eurasian, and see the boundary also, how big it is and all you have to see. Second, African plate, you notice. North American plate. Fourth, South American plate. Fifth, Antarctic plate. Antarctic. Sixth, Indo-Australian plate. Notice India and Australia are part of one plate, major plate. India and Australia together it is called as major. And the last one, seventh one is Pacific plate. So how many major plates are there? Seven. Seven major plates. Among these seven, first six are continental plate. Do you agree? Last one is oceanic. Pacific is the oceanic plate. So you can write a flower bracket like this, and first six is continental plate and the last one is oceanic plate. All of you understood this? Continental, oceanic. If there is more continental crust visible, continental plate. If there is no continental crust, oceanic. So they have asked this question, how many major plates are there? 7. What is the criteria? Size? More than 20 million square kilometers. Check the atlas. Check the atlas boundary also, you notice how big the plates are. That atlas page you change, that is not the page. Change the page. This turn. This one. What is the page number in Black Swan? 85. In Black Swan. Done with the boundary. Now I am going to mention smaller ones now. Minor. I want you to see the board now first. When I write, use locate it first. Notice this. Nazca next to South America. West of South America. Nazca. Scotia below Nazca or below South America. All of you know the continents? Below South America, Scotia. C. Above South America, Cocos and Caribbean. Okay, around South America. They are asking this now. Questions are coming from this as of now. So Caribbean, Cocos, Scotia, okay, Nazca. Now come towards Africa. Nubian plate, you write, I will explain. Nubian, or you notice Arabian plate, Somali plate. This I will show you. These two I will show you. Okay, Arabian plate you can notice. E and G I will show you. Somali and Nubian. Next, Indian plate. Or wait, not Indian. I will show you this one. Anatolian plate, Turkey. Anatolia. This is Turkey. Persian plate means Iran. Now all this is in news. All these new plates are in news. Indian. Burma plate. Burma means Myanmar. Sunda plate, Indonesia. Below Burma is Sunda, bracket Indonesia. Okay, next is Philippine plate. Philippines. Next to that is Caroline plate. कैरोलिन प्लेट के नीचे हेब्राइट्स. नेक्स्ट सोलोमन. Australian. India and Australia together it is major. Sixth, you can see India and Australia together major, but only Australia and India separately they are minor. Solomon, Australian. Okay, almost all we have written. Please notice them if they have given. Notice Most of it is not given, but I have written all the minor ones I have written. Micro is very small. This is not important. Like micro is like Panama. Have you heard of Panama? Very small, Panama. Fiji, Tonga, Juan de Fuca. Only this is given in your atlas. Next to North America. West of North America they have given this. Check it out. Okay. Next to North America you can see Juan de Fuca plate. Persia is Iran. Sunda is Burma. Sorry, Sunda is Indonesia. Here, Sunda plate is present day Indonesia. Burma is Myanmar. So in many exams the questions are coming from minor. Whatever possible you locate, whichever is given, because I don't know which atlas you are holding. Some of you have different atlas. Whatever we have seen in the atlas, whichever you have seen in the underline. Okay. At least now you know. Okay, how many of you can locate all this? Next to Philippines comes Caroline. Below that is Hebrides, then Solomon. Okay, and then Australia. Between Philippine plate and Australia, we have these three small ones. Notice this: Philippine plate and Australian plate के बीच में we have these small ones, minor ones. Indonesia is this Sunda. Okay, this is Indonesia. Persia is Iran, next to India. West of India comes this Persian. Like Afghanistan and Iran is located on this plate, Persian plate. Okay, like that. Whereas Pakistan is located on Indian plate only. Indian plate. Okay, that much you should know. Major, minor, micro. So the lithosphere is very fragile, very delicate. It is broken into small pieces, and all these are independently moving in different direction. That causes earthquakes and volcanoes. In your map, wherever you are seeing that, if you see the boundary now, check the boundaries now. Along the boundary only we get most of the earthquake and volcanoes. In that particular map, what you are seeing is a geology map that helps us to understand, to know the distribution of earthquakes and volcanoes. Wherever you see the boundary, there you get most of the earthquakes. Notice India. To the north of India, you notice the boundary, Himalayas, that one. Lot of earthquakes occur. Whereas South India, notice South India. North India is close to the boundary. South India is safe because we are away from the boundary. Like that you should be able to understand. So we are sitting on a plate here, Indian shield. This part, especially what we are seeing, is a very old rigid block of earth. Very stable. No earthquakes will occur here. Okay. So this is all South Indian part. Very stable rocks. No fractures, no boundaries, as a result, stable. Unless if you are building dams, you are exploding bombs, mining, quarry you are doing, correct. If you are not doing any of this, nothing will happen. If you do that, it can trigger earthquake. Man-made earthquakes will occur. Otherwise, nothing will happen. We are in a safe zone. But in Himalayas and all, you will never know what is going to happen when, because very fragile. Boundary. Notice Japan now. Try to locate Japan in that map. Above the Philippine plate. Japan is located in the boundary of 4 plates. It is called as quadruple junction. Notice to the north of Philippine plate. That is Japan. Japan is between North America, Pacific plate, Eurasian plate and Philippine plate. See, some of you are not bringing the atlas, nor you are seeing atlas, nor you are paying interest. I am telling you, I am not responsible. I am trying my best to show you the videos necessary, documentaries. I am writing everything on the board. Normally we don't write, if you ask me. We just ask the students to see the atlas and I dictate. I am writing on the board. Despite that, if you are not showing interest, I am not responsible. I am telling you now only. Okay. So we need you also to contribute. This is a two-way. Teaching is not just one way. It is a two-way road. So I am telling those students who are not paying attention. So now notice that now quadruple junction bolte hain isko. Quadruple means 4 plates. Quadruple junction, which Japan. That means even one of them moves in the surrounding of Japan, Japan will experience earthquake. That is the reason Japan has so much earthquakes. On a daily basis, 20 earthquakes occur. 20 earthquakes on a daily basis. Okay. Tsunami is so common for them. Earthquake, tsunami, volcano. There are hundreds of volcanoes they have. Okay. Like that. Philippines also, Indonesia. Okay. All this you should know. Whichever place is on the boundary, then you should know. Okay. You might say, sir, lucky we are not there. But one day you might go there as a tourist. Correct. You will forget our geography class and you will go there. Then, oh, you will realize. Correct. Allah. So you should know where you are going, what type of place you are visiting. Okay. Quadruple. Quadruple means 4 plate. 4 plate. Junction of 4 plates. If there are 3 plates, tri-junction. Tri-junction is what we use for 3 plates. Okay. Notice Turkey. Here. Above Arabian plate, this one. Above Arabian plate, you notice all of you. Africa, Arabian plate, Eurasian plate. 3 plates, this is tri-junction. They're only same. Here. Africa, Arabian plate and Eurasian plate here. This is called as tri-junction. 3 plates are meeting here. Wherever 3 plates are there, that is in Turkey earthquake hua. Turkey mein. Turkey, the most severe earthquake happened recently. Remember last 2 years mein. That is because of that place. Tri-junction plate. Okay. Between Africa, Arabian plate, Eurasian plate. Here, this is Turkey. You write T. T. Turkey. This is T. Okay. Our Burma region is also tri-junction, Northeast India. Northeast India, dekho, Northeast India here. Eurasian plate, Indian plate, Burma plate. There is also tri-junction. Northeast India region, it's part of Indian plate, Burma and Eurasian. 3 tri-junction. Okay, Burma plate is not given in many atlas. Which atlas they have given? Have they given in that atlas? No. This one? No. Orient Black Swan they have given. That is the reason I told you. 2 atlas will help you out. Okay. That is reclassified recently into Burma Minor. Burma Minor. Dekho. Because the area of Burma plate is 11 lakh. What is 11 lakh means? More than 1 million na, in this range. You got it? 11 lakh comes under means 1.1 million is यहाँ पे आ जाएगा इस range में. So it was reclassified from micro to minor. Okay. All of you got it? So like this topic will help you to understand distribution of volcanoes and earthquake. Okay, where earthquakes occur, where it is safe. Even if you are in the boundary, what type of infrastructure you should do, what you should not do. This topic will tell us. That is then Japan removed all their nuclear reactors because they know they are in a very fragile region. If there are nuclear reactors also, it will damage their economy. That's what happened in Fukushima. Fukushima disaster 2011 May, the earthquake occurred near the reactor. So the radiation followed, killed 11,000 people in just half an hour. As a result, they shut down all the reactors. Correct? So that will help the government to decide what is best for their population. Imagine I am building a nuclear reactor in Himalayas. Wrong. We should not allow. A big reactor, big dam we are building. We should not allow big dams. Why? It can exert lot of load on the fault zones there. It can trigger mega earthquake. That will cause damage to the dam also. It will cause severe flood also. Surrounding regions will get washed out. Okay, so we have to understand the fragile ecosystem here. So this topic will help us to make a better decision for our people. Okay, so that is where you all come into play. You should know all this. Okay, because civil servants will understand all this. Politicians don't know all this. You have to tell them, no sir, this is happening here and so and so. Then okay, they will say okay. Okay. As a result, these topics are very sensitive to other aspects like ecology and all, landslides, earthquakes. Okay, I'll discuss this again in the landslide class. Landslide class. So as a result, wait for that. Now, plate boundary next. Plate boundary or margin. That boundary we are discussing now. First one, diverging boundary. Diverging boundary. Already we have covered this. I gave you 4 diagrams, remember? Diverging boundary. Means what? All of you notice this? The 2 plates were there and they were diverging, means what? This arrow mark. All of you understand the arrow mark? Simple diagram I have given. For diverging, pay attention all of you. 2 plates are moving apart. What happens to the magma below? Here, magma is here. The magma comes up, becomes lava here on the surface. Lava. Don't you think the lava will cover on the surface, cool, solidify, becomes rock? New rock is formed. New crust is created. New minerals are deposited on the surface. So diverging boundaries are called as constructive plate boundary. Rachanatmak means new crust is created. So diverging boundaries are called as constructive. Also called as spreading boundary. In geology we use spreading boundary. Spreading bole to separation. So simple diagram I have given because I am starting the topic. This will cause volcanoes, yes. Earthquakes, yes. Where? Here. This region will experience both volcanoes and earthquakes. Remember we have done 4 diagrams here. This 4 diagram. 1, 2, 3, 4. See the arrow mark? All these are the 4 cases of that topic. You have to repeat that. Same. This led to formation of rift valley, sea, oceans, ridges. Same thing you have to write. Only thing now you are writing under the different heading. Here only, I think in this diagram I gave you the separate one line I gave you. This comes under diverging boundary also. Just now. This is part of diverging boundary also. I think I have given that statement somewhere. There you have to repeat that. Otherwise, I have to write it again. It will waste my time here. So you just copy this and paste there. Okay. Please remember this. That topic will come here. Diverging boundary, spreading boundary. Okay. This led to the formation of rift valleys. Correct. Rift valley form hua. I'll explain again if you want. Not a problem. Sea was formed, ocean was formed, ridges were formed under the diverging boundary case. Diverging. Okay. You leave some space. I'll quickly write. You leave the space. Okay. Similarly, you have to write the other two. So you can notice this in these two cases, it is the continental crust separating, correct? Continental crust separating. So I'll call this as CC. Continental crust, continental crust. I'm adding one letter now, that's it. Continental plate separating. Okay, continental plate. Here you notice the continental plates will diverge. Okay, this is A, this is B, this is C. The continental plate will diverge. It becomes C now. C is formed. Because of volcanic activity, what is happening? The oceanic crust is formed. The oceanic crust contains volcanic rocks. Here, oceanic crust contains more volcanic rocks, so it becomes denser. So oceanic crust here is denser. Oceanic plate, this part. This is called as oceanic divergence. Because of new volcanism here, every day there is lava coming out. The crust is formed. Oceanic crust is formed. The magma brings a lot of molten material. It contains more minerals, and all that minerals will deposit on the ocean floor, making it more dense. So ocean floor sees more volcanism, regular volcanism, than continents. Oceans have more volcanic activity than continents. So ocean floor constantly get renewed by new deposition of lava. So that is the reason oceanic crust is younger than continental crust. Remember the statement. I am saying continent, यहाँ पे volcano कब हुआ यहाँ पे हैदराबाद region में, very long back, 600 million years ago. Golconda rock is a volcanic rock. After that we have not seen. Have you noticed any volcano now? No. But ocean floor, recently there was volcanic activity in the water bodies around us. Oceans see volcanism regularly. Lava keeps coming out, depositing on the ocean floor, increasing its density. Whereas continental crusts are older, oceanic crusts are younger. Please write the statement somewhere. Oceanic crust experiences volcanism more regularly than continental crust. All of you are able to understand? Oceanic crust experiences volcanism more regularly than continental crust. Oceanic crust experiences volcanism more regularly than continental crust. So oceanic crust is younger than continental crust. Okay, means you'll get young rocks here if I go. Okay, oceanic crust is younger than continental crust. So please notice this. In the center here the volcano is taking place. This is active. The older ones will be away. The older ones, extinct ones, volcanoes will be away from the ridge here. The younger ones will be in the center. I'll call this as like 1 1. This is 2 2, 3 3, 4 4. 4 is the new now. So here in the center the volcano is taking place, so it is young. The other ones, older mountains, rocks are away. Okay. So what scientists have done now, they have collected the rocks from here and here, and they have matched. It appears same, of same age. 1 1 is of same age. Okay, I'll do one thing. I'll write again. This one I'll write. Next is ocean. The ocean floor will spread apart and becomes oceans. Oceanic crust, you notice here. This is all ocean here. Here I'll explain that topic. Here you can notice here. This is the younger, I'm saying. The older ones are here. They'll move apart like this. I'll call this as 1 1 here. 2 2. These two were formed at same time. 3 3 were formed same time. Fourth is here, this one. The fourth is the youngest one, recently formed. The oldest one is away. The oceanic ridges, we are talking about what? Oceanic ridges or mountains on the ocean floor. Mountains on the ocean floor ke bare mein we are talking. These mountains are formed due to volcanism. Yes. The youngest, newest volcano will be in the center of the rift. The oldest will be away. Okay. when we collect rock from this and this, we'll come to know that they are of same age. That means our crust was here like this earlier. Then slowly they are spreading out Allah. This tells us what rate the plate is moving. This rock was here earlier. Since the crust is moving apart slowly, these two have gone out. Then 2 was formed, second was formed, then third was formed, then the fourth. After few years, what happened? The newest will be formed here. Again, further I'll show you one more diagram. Last. Four, three, two, one. This is 5 now. The 5 is the recent one. Now all of you got it? What is the difference in this and this image? There is a new volcano now. That is 5th one. The oldest 4th is also moving out. Oldest of all is 1. So what scientists are doing now? They are collecting rock sample here and here, here. They are matching with each other. Okay. So earlier it was here. Now it has shifted slightly. Correct? So what rate the plate has shifted, we can calculate. Because every time the new rocks are formed here, the older ones are moving outward. By moving outward, what is happening? The newest is formed in the center. These rocks are comparatively younger. They are present generation. This is many million years old rock. Many million years old rock. This will help us to understand how fast the plates are moving. Tectonic activities are happening. In what direction it is happening. With the help of this information, we now know that Indian plate is moving at the rate of 47 mm per year. Per year, our tectonic plate of India is moving at what rate? 47. I'm just giving an example. So this will help us to understand the past history of the earth. Earlier how the rocks were, how it is now, what type of minerals we get. Correct, ocean mining, I told you, deep sea mining will help us understand this. We'll get access to minerals. So by studying this, correct, we'll come to know about the past. Let's say we go and collect these rock samples like 1. Study the magnetic properties, because these are all magma. When the magma comes to the surface, lava. Lava contains a lot of iron bearing minerals. When the iron bearing minerals cool and solidify, they'll record the magnetic field of the earth. Direction of the magnetic field and all, they'll record and solidify. So they record the past magnetic field and they solidify, giving us the information about the past history of the earth. How was earth earlier and how it is now. The study of magnetic properties of the rock is called as paleomagnetism. Paleo means old. Magnetism, all of you know. The study of magnetic properties of ancient rocks is known as paleomagnetism. I'll repeat. A study of magnetic properties of ancient rocks. Magnetic properties of ancient rock is known as paleomagnetism. Paleomagnetism. During the volcanic activity, I'll dictate this concept, please write. During the volcanic activity. During the volcanic activity. During the volcanic activity. Please continue. During the volcanic activity. The iron bearing minerals in the lava. Iron bearing minerals, spelling on the board. Iron bearing minerals. Iron bearing minerals in the lava. Okay. Iron bearing minerals in the lava. Record the intensity and direction of the magnetic field. Record the intensity and direction of the Earth's magnetic field. Intensity and direction of the Earth's magnetic field that existed at the time of its formation. at the time of its formation. It can be, it could have formed now, it could have formed many millions of years ago. Whenever it is formed, it would have recorded the magnetic field and it would have solidified, thus giving us the permanent record. That means that record will be stored there only, that information will be stored. We have to go and collect and see, we'll come to know how it was Earth earlier, how it is now. So what did you write? Study of magnetic properties of ancient rock is called as paleomagnetism. So I am saying during the volcanic activity, the iron bearing minerals in the lava record the intensity and direction of the magnetic field that existed at the time of its formation, bracket solidification. Because when it solidifies, what happens? It records the information at the time of its formation, thus recording at the time of its formation, thus recording the magnetic field, of the earth. Please remember, so every time the lava comes out, it brings iron containing minerals. When it solidifies here, it will record the magnetic field that is present now. Okay, the old rocks would have recorded the past magnetic field of the earth, because earth magnetic field is changing, place to place it changes. That record is there in the ocean floor now. So paleomagnetism helps us to understand the past of the earth, the rate of plate movement, direction of plate movement, everything is recorded by the earth's rock. As we advance, the technology advances, we are getting more information from the ocean floor, and that will help us to understand about the continents, how it was earlier. So this is the one which gave us information about the continental drift. Okay, I'll write see, this is what I was talking about. See, this is the ocean floor. Can you all see ocean floor? This is magma here. Dekho, magma is coming up, lava. It is solidifying na. This is ridges, oceanic ridges. This is showing the present. Many millions of years. So see here, this red. Many millions of years. See red. That is different rocks, different composition. But iron bearing minerals will record the magnetic field that existed at that time. Then again changes. Then again. So this will come to know. When you go and pick up the rocks on either side, we can match them. So it was here earlier and it has moved this way. This has moved this way. How much they have moved, we can understand. Direction of movement we can understand. See the arrow mark here, they have shown. So that is the reason I was telling you, collecting data from the ocean floor is now important. That is the reason India is sending oceanic vessels to the ocean floor. Correct, Matsya 6000 I was telling you. Sagar Nidhi, we have ocean vessel. So India is actively taking part in this kind of research now. So it is going to come. I am telling you, this topic mark it as star, double star. Paleomagnetism. The topics which are not there in the book, which is nobody is talking now, will come. If you are hearing this for the first time, that means it is going to come. Paleomagnetism. Okay. Till now no questions, but they will ask. So I have done a lot of videos of this also. I will show you that. One more image is there I wanted you to see. Just a quick topic, okay? So we have done this across the world now. Everywhere, on either side of the rocks, around the world, ridges, wherever the ridges are there we have collected the rock samples on either side, you notice. You can see the red, then slightly orange, then yellow, green, light green, dark green. Have you noticed that? That is all showing the age of the rocks. Age of the rocks. We are studying the magnetic properties of ancient rocks now. Okay. So around the world, almost all, everywhere the research is being done now. The red indicates the recent, you see, 0. We can see the million years before present. BP means million years before present. This blue is oldest. So they are showing colors for you to understand easily. For us, we understand technical words. For students who are listening to this for the first time, they'll be wondering, what is this happening? All new topics coming up. I'm telling you, wherever I have done some new topics which is not there in the books, regular books, those like gravity anomaly, correct, Indian Ocean geodal low, magnetic field, all those questions are expected. One more image, last. Where is that? I had uploaded somewhere. Wait. Not this one. Here. This one. I was looking for this. Here. What I have done, we have collected the rock samples from either side. The magnetic field direction we have shown. See the magnetic compass. So the present magnet, how the minerals align. This is present. The oldest, older than this. So different magnetic polarities we have recorded here. Because every time the iron bearing minerals come and solidify, they record the direction of the magnetic field. Just like if you hold the compass now, what is the direction of your needle? That is recorded by that rock also. Older than that, that is also recording the magnetic field that existed back then. So it is showing the past magnetism, how the magnetic field of the earth is changing. So this is record we have. Okay. So all this is called as what? Simple word, paleomagnetism. Study of magnetic properties of ancient rocks. Ancient means this. Ancient, many millions of years old, is paleomagnetism. Simple paragraph I have given. That paragraph, if you read, you will understand. Okay. The lava comes out, the iron bearing minerals will record the magnetic field that existed at the time of its formation. Okay. So please remember this diagram. Is it clear, this one? So diverging plate boundaries have played a very important role in understanding the direction. So diverging, also called as constructive, also called as spreading boundary. Okay. So where is this happening? Presently, where is this happening? If you are wondering, let's say this is plate, continental plate, where is this separation taking place? See this diagram and this diagram. Notice this and notice this. There is a rift valley formed, correct? So we will see this present African plate is now spreading out now. We call it the Great African Rift Valley. I'll write. See this. So Africa is now gradually splitting into two like this. This is the Africa, correct? This is Arabian plate. Notice that Arabian plate here is moving in this direction. In this direction. That led to the formation of Red Sea. This is Arabian plate. Somali plate is going in this direction. This is called as Somali plate. I have already given this. Somali. This is called Nubian plate. Nubian plate. So there are three parts now. Arabian plate has already got separated long back. Okay. Now these two are separating. Somali and Nubian. So slowly they are moving apart like this. So next few million years, the new sea will be formed here. Remember, diagram, sequence of diagrams, A, B, C, D. So this is C, D. Okay, as of now, we are in this stage. As of now, the plates are getting separated. For this to happen, another few million years are required. Okay, but now you notice, where is Nubian plate? This part. Where is Somali plate? This side. Arabian plate. In tomorrow's class, I'll write this again. Okay, for now, at least you should know, okay, whatever the topic we are reading now, where it can be applied. Okay, so I'll show you one more last image, then we can stop. See, this is present now. Now, last week, you can notice Africa is like experiencing this kind of separation now slowly. Okay, in many places, you can see the land for millions of kilometers, sorry, thousands of kilometers, you can see the plates are slowly moving. This is present, recent. This is happening in Africa now. Since it is happening in Africa, So nobody is talking about it. If the same thing, if continent was splitting somewhere else, it would have been a big news. Correct? The media would have gone there and put up camera and all. Since it is Africa, nobody is worried. Correct? Even the people there don't care. They are going there taking selfie and all now. Okay. So we have see this now. Can you see this? Now Africans are like roads and all are getting separated. Bridges and all they are trying to build now. Because land is slowly splitting. So I'll show you this last part, African Rift Valley. Go to Africa map quickly. Notice this here. This is Somali plate, this is African plate, Nubian, and this is Arabian. You can notice in your atlas from Mozambique, start from Mozambique, you can see a line like this. Like this, you can notice. Africa physical map. Turn the page. No, only one page you will turn. 84. Notice this please here. Red line is given. Notice the red line here in Africa. From Mozambique here, all the way from Mozambique to Upper, tak, red line. Follow the red line. Follow the red line. That red line is showing what? It is showing the Rift Valley. This line, it is showing this part. The red line in the atlas is showing this and this part. Okay. So that in the middle is water. You notice that Rift Valley ka what pani hai dekho in the middle. Can you notice so many lakes? Rift Valley lakes. Those are all. Start from below Mozambique. Go up like this. So many lakes. Tanganyika, Nyasa, Albert, Edward, Q. So many lakes. You go up like this. Except Victoria. All the other lakes are Rift Valley lakes. Notice the one thing. Rift Valley lakes are linear in shape. Linear. What is linear means? Line jaisa aega. There is the clue. If the lake is like this straight, it is a Rift Valley lake. Normal lakes are round shape. Okay, देखो Rift Valley lake है. ये भी Rift Valley है. Gulf of Aden, Red Sea is also Rift Valley. Follow the red line. It goes up to Lebanon. ऊपर Lebanon तक जाएगा. Beirut. The line here, you can goes up to Beirut. Here, see here. In this atlas, see here. This is Beirut. Dead Sea. Here. Israel, Jordan border up to Lebanon. Here. It goes up to Israel, Lebanon border. Palestine border. Upar tak. This is the longest rift valley on earth. So it's called as Great African Rift Valley. They'll ask, discuss the formation of Great African Rift Valley. Same answer. Diverging boundary. But continent you have to mention is Africa. One side is Somali plate. Somali here, Somali. This side is Nubian. This side is Arabian. Okay, please remember this, very important. This is the future topic. Discuss Great African Rift Valley with a suitable diagram. That is the reason Africa is experiencing a lot of earthquakes, volcanoes. Here, look at one peak, Mount Kilimanjaro. It's a volcano, highest peak of Africa. Mount Kilimanjaro. Here in physical map. Mount Kilimanjaro. That is the highest peak of Africa. It is a volcano. Okay, it is a volcano. Okay, we'll stop now. Great African Rift Valley. In tomorrow's class, I will finish converging boundary. Diverging is over today. African Rift Valley. I will draw the diagram and we can continue with the new topic. Anybody with the answers? What is this? Keep one notebook. Next time you will start writing on tissue paper if I don't say anything. So maintain one book. Okay. I got it. I got it. See, this is a not yet confirmed. So directly you can't write this. Write in the conclusion. Ah. Carry on, please. Yes, you can go. This notes you want. This is you can change. You can just write Earth. We have covered first one, diverging plate boundary. Okay. First is diverging. The topic is plate boundary or margin. Plate boundary or margin means what happens at the boundary of the two plates. Diverging plate boundary, or also called as spreading boundary. I told you. Whenever the two plates spread out, new crust is created. Correct. New rocks are created. New minerals are created. The crust gets expanded. Correct. Sea floor and oceanic crust is created. 1 second. Okay, sea floor and oceanic crust is created. Correct. So that means every time when there is diverging of plates, new crust is created. So it is called as constructive plate margin. Constructive plate margin. Please remember this. Or plate boundary. Here we have discussed 4 diagrams we wrote. Remember you wrote 4 diagrams for this. First 2 diagrams AB for continental crust. Second 2 diagrams are oceanic crust. How the sea floor spreading takes place. Okay. Example. I had given one example. Okay, Africa. Presently Africa is undergoing this now. Quickly draw the diagram so that we can continue. This is Africa. See the atlas. This is Africa. See this. This is the Rift Valley. This is Arabian Peninsula. Arabian Peninsula is separating from Africa. Correct. This got separated many millions of years. Arabian Peninsula. This is Somali plate. This is Somali plate. This is Arabian plate. This is Nubian plate. So African part is divided into Nubian plate, Somali plate and Arabian plate. 3 plates separating. These are all minor plates. Together it's called as major. Together it is major. Okay. Individually if you take minor. So what happens? The divergence occur. Crust gets stretched. As a result, new crust is created. So slowly you can see the Rift Valley. On either side of your atlas, you can notice the Rift Valley mark is given. Red line is given. Like this. That Rift Valley goes up to Lebanon, Beirut. The Rift Valley starts here from Mozambique. And goes all the way up to Lebanon. Please check that Africa map. Africa, yesterday's class, you are seeing Asia. Go to Africa. Next. 1 second. This one. See this red line. Start from Mozambique in the south. Okay, imagine this is one side is one plate separating from the other. In the middle, the gap will form this Rift Valley is called as Rift Valley. In the Rift Valley, river will flow or water will collect, forming lake. See here, in the classroom, this is the Rift Valley, let's say. This is the Rift Valley. How is the shape of this Rift Valley? Like a linear shape. So water will collect means it looks like what? Like this. That is the reason most of the lakes are linear shape. Linear lakes है, linear. देखो ऐसा. linear. All the lakes are like this. And Red Sea is also Rift Valley Sea, correct? Red Sea, Gulf of Aden. This is a definite question. Discuss the formation of Great African Rift Valley. This is called as Great African Rift Valley. Great African Rift Valley. Then it is a case of what? Diverging, spreading boundary. In this case, what? How many diagrams will you write? This one you write. And in the 4 diagrams, you have to write first 2. First 2. Yesterday we gave 4 diagrams. In that you write first 2. Okay. Because the Rift Valley they are asking. They are not asking formation of sea or ocean. If you want to show, you can say write 3 diagrams. A, B, C. C is about sea formation. You can show how the Red Sea was formed. Anta. Write first 3 diagrams. Okay. The first was the continent spreading out like this. Due to the convection current. Here, convection heat की वजह से. Like this magma is formed, Rift Valley is formed like this volcano. This is first case. Then second case में we showed the Rift Valley formation like this. These are faults, fractures. You can see many volcanoes are formed here. Like this, you can see volcanoes. This is Rift Valley. Africa is in this case now. Further it will spread out. Finally, it will become a sea. One day it will become a sea. Rift Valley will become sea. Like this. This much you write, ABC. If they ask you, discuss the formation of Great African Rift Valley and the future of Africa, you write up to this. That means there is going to sea formation in future. I showed you this photo yesterday, how the Africa is splitting. So there is a series of earthquakes and volcanoes are taking place in Africa now. Every day. You got it? This itself is around 8,000 kilometers stretch from here to here. So there's every day they are facing vibrations, shivering, earthquake, volcano. That is the reason I told you the Mount Kilimanjaro highest peak itself is a volcano. Africa ka highest peak itself is a volcano here. I told you Mount Kenya also, Mount Kilimanjaro. All these peaks are what? Volcanoes. वहाँ पे जो भी peak है triangle volcano. I'm marking this as very, very important. Certain questions that I say will come in the mains or prelims. Okay. Done. So diverging, I think you have no doubt. We have covered it extensively. Okay, with examples and all. Diverging, spreading or constructive. Why constructive? Because new crust is created. Next, shall I go to the next page? Okay. Which are the minor plates involved? Somali, Nubian, Arabian. Okay. Now, next case is constructive. Oh, sorry. Next is converging. Converging plate boundary. Converging means colliding. Colliding. Boundary, plate boundary. So when I say colliding, it means like these two plates are there. They are colliding with each other. Like this. See the arrow mark? Notice the arrow mark? Like this. Okay. That means whichever is denser. Let's say this is dense plate. What happens? The denser plate goes down. All of you understand this, please. The heavier plate goes down, subducts. The other plates here, all of you, simple diagram like this. It goes up. This one goes up, forming islands, mountains this side. Because this is low density rocks. Low density folds quickly, accretes quickly. Accretion takes place and folds. Okay, the other denser plate goes down. Notice this how it looks. Correct. This one becomes like this. It goes up forming islands, mountains. The other one goes down forming subduction. Notice this side, let's say if it is water here, this becomes a trench. This is a trench. Trench is formed. Okay, so this is subduction, we call it as. Subduction means, what is sub? Go down, below. Duct means to go down. Okay, subduction hoga. Please notice, this will go and melt here, correct? The magma comes up, causing volcano. We saw the video yesterday. The plate goes down, melts, comes out as magma. So we have volcanic mountains, islands here. Simple diagram I have given. So what is happening here? Notice, during convergence, one of the plate is going down, subducting down and getting destroyed, correct? So converging boundaries are called as destructive plate margin. Destructive plate boundary. Because the plate goes down and gets destroyed. Gets destroyed in the process. Can I continue? Done? In these three cases are there. Oceanic plate, oceanic continental plate, continental. Okay, oceanic plate, oceanic continental, and last one continental. Okay, first two I'll cover now. Okay, first one oceanic. First one oceanic plate. Remember yesterday I told you continental plate, oceanic plate. What happens when the two oceanic plates collide? See how it looks. The two oceanic plates are like this. Both are under water because oceanic plates are under water. It is already under the water. This is the boundary, let's say. This is the boundary. The two plates are colliding, converging. Okay. So these two oceanic plates, let's say one of them will be major, other one is minor. Let's say Pacific plate. Pacific plate is also oceanic. Philippine plate is also oceanic. So both of them are colliding. So Pacific plate is major plate and it is also having denser rocks. So it goes down. Among these two also we check the density. So the whichever is having higher density will obviously go down. Subduct. Heavier plate always goes down. Pacific plate is denser. So it goes down. Subducts. Like this. Okay, please notice deep subduction occurs like this. It goes down. Like this. The other plate is low density plate compared to this. So it will buckle, bend. So forming islands like this. Islands and all. This is going up, one is going down. See. So deep subduction occurs. Both of them are underwater. See, don't forget that. Both of them are underwater. So I have to write water here also. Because many students while writing, they write water one side. Other side they won't write because these are oceanic. So it is surrounded by water. So these islands form here. Notice this deep subduction is taking place here. Very deep. So we'll have a very deep trench. Mariana Trench. Mariana Trench is the deepest trench formed when two oceanic plates converged. That is the reason see, oceanic plates are already many meters deep. Correct. Already 3000 meters deep. 3000 meters deep. Further it will go down means what? Another 6000 meters it will go down. Deep trench. That is the reason Mariana Trench depth is 11,000 meters. From the sea level. From the sea level, what is the depth of Mariana Trench? Nearly 11,000. 11,000 se upar hai. Okay, the deepest trench is formed in which boundary? They will ask. Oceanic. Okay, we have a deep trench here, and this subduction boundary you have to remember. Subduction boundary. This is subduction. So as it goes down, don't you think earthquake will occur? Here I told you, earthquakes, series of earthquakes will occur. Earthquake I am writing in yellow color. All of you pay attention. Whenever I write this yellow cross, indicates earthquake. Deep earthquakes. This color indicates earthquake. Okay, earthquake. Deep earthquakes will occur. Part of the plate will melt also. Melt. It comes out as volcano. So volcanic islands are formed. Volcanic islands. Clear? So this is how Mariana Trench was formed. So the Mariana Trench example, what we gave now, example, Mariana Trench, world's deepest trench. Okay, it is 11,031 meters exactly, minus 11,000 meters below sea level. It is formed due to Philippine plate colliding with Pacific plate. They'll ask, Mariana Trench was formed due to which of the following plates? Okay, then you have to write Philippine plate, Pacific plate, Philippine plate, collision. Arrow mark dekho, arrow mark. Means collision. Earthquake, volcano. So locate Mariana Trench in the atlas. Go to Asia map, Asia Pacific map. Yesterday we saw the map, Asia map. Locate Mariana Trench. One second. I'll show you. See here. This is the map. Here, this corner here, Mariana Trench. This corner. Page corner, this side. Mariana Trench. Mark 11,022. They have given 22, but it has become now 31. 11,031 ho gaya ab. Because subduction keeps taking place, going on. So new data says 11,000. Okay, I'll tell you one more information. Let's say this classroom is a trench. This is a trench. I am standing here. This point is further deeper than this point. That deepest point is called as Challenger Deep. Mariana Trench के अंदर भी deepest point है. You got it Allah? Trench के अंदर भी, let's say this is a trench. ऐसा होगा trench. Like this. This is Mariana Trench. This is the Challenger Deep. I have written Challenger Deep का depth. Challenger Deep बोलते हैं इसको. The deepest point within the trench is called as Challenger, because the British sent one oceanic vessel to study this. The ship name was Challenger. The name of the ship was Challenger, so it's called as Challenger Deep. Okay, it's a research vessel. The ship name was Challenger, इसलिए उसका नाम Challenger Deep. Done. So this is one part. How oceanic plates will result in deepest trench. Notice that earthquakes will occur deep into the earth. Starting from here, correct, all the way till deep, earthquakes will occur. This zone where the deep earthquakes occur, up to almost like 560 kilometers deep, earthquakes we have noticed till now. From the surface here all the way down. Whenever earthquakes here occur here, it will trigger tsunami. Underwater earthquakes will trigger tsunami here. But deep earthquakes will not trigger anything. Just earthquake. But shallow here earthquakes will occur. Shallow earthquakes will occur. Tsunami. Remember, this zone where the deep earthquakes occur are called as Benioff Vodati zone. Benioff Vodati zone. Mark it as very important. Mark it as 3 stars. Nobody knows, it will come. Not mentioned in the books, regular books. What is Benioff Vodati zone? Certain things I mention, keep it to yourself. Keep that information to yourself. Why? When it comes, you should be in advantage. I know I shouldn't be saying that. Students, correct. But we want our students to clear first. Okay, so make sure that you keep your notes intact. Keep it ready. So when this comes, you'll know, okay, sir had told once it will come anta. When it comes, you'll know in the paper. Okay, Benioff Vodati zone. Benioff Vodati zone, they'll ask. What is Benioff Vodati zone? This is a deep focus earthquake zone. Deep focus earthquake zone up to the depth of 560-600 kilometers. Deep focus means into the asthenosphere. When the plate goes into the asthenosphere, the earthquakes keep happening. It's a deep subduction zone. Okay, deep seismic zone. Name of the scientist. Who are these two people? Benioff is one scientist. Vodati is another scientist. Two scientists who mentioned it. Benioff, Vodati. Clear? So remember this. Oceanic. We have discussed. Next, second one, oceanic continental. Let's say one plate is oceanic, the other plate is continental. Notice this, the oceanic plate is colliding with continental here. One side is oceanic plate, other side is continental plate. We all know continental plate is Sial. Remember, oceanic plate is Sima. Sial is slightly lighter. Sima is denser. Continental crust. So when the two plates collide, the oceanic plates are denser than continental. So as a result, what we know is the oceanic plates subduct. Oceanic plate subduct under the continental. Whereas the continental plate here have low density rocks, so they buckle quickly, bend quickly, forming mountains. Islands are not formed, they are formed mountains. Islands are also formed in the coast here. Small islands will form, then mountains are also formed like this. Okay, so islands and mountains are formed. Please write like this. Series of, in this side, okay. One side water now. I am writing water one side, correct. Because this side is continental. This side is continental plate. So we have trench also, small trench. Subduction. This is going up, abduction. Abduction means to go up. OB. Okay. इसको ऊपर जा रहा है ना, इसको abduction बोलते हैं. Going upwards. Going down is subduction. Here the sediments are all will fold and bend in the edge, corner. In this, where is compression taking place? Most of the compression is in this boundary ला. Compression कहाँ है? यहाँ पे boundary में है. So यहाँ पे bend होगा sediments. Fold mountains are formed. Fold. Sediments are folded. Fold mountains are formed. Okay, let's say in your notebook, keep your notebook like this. Open the notebook, keep it like this flat. Okay, so keep your hand on the either side. And on either side. Push it closer. What happens to the paper? Folds. You got it? Simple as that. When the two plates come together, the sediments, what happens in the middle? Gets compressed. You got the experiment. So you keep your hand on the mat or a table mat के ऊपर. If you bring your hand closer, what happens? Notice that mat folds. Same. Here the compression strength is more. Here in the experiment I am showing you with the help of the hand. But here rocks, continents are colliding. Plates are colliding. So imagine the strength involved, force involved, energy involved. So as a result, rocks will buckle, bend, forming mountains. Okay. So mountains form. This is what we call as accretion of sediments. Accretion bole to come together. Correct. All the sediments will come together, go up. So accretionary wedge bolte isko. Accretionary wedge leads to the formation of fold mountains. Accretionary means accrete means to come together, to gather. That is the reason mountains look like this. Next time you see any mountains, कैसे दिखेगा? देखो ऐसा दिखेगा ना. Have you noticed? Mountains look like this. Correct. Because what? They are all folded, and all the sediments have come together like this, got compressed, so they have become like this. So the name accretion. Accretion means to come together. Fold mountains. Done. Trench. One side, other side mountains. Islands and mountains भी हो सकता है. कभी कभी island भी होगा. यहाँ पे देखो island, mountains, ऐसा series of mountains आएगा. Okay. Here you can see the plate is going down, so it will melt here. Earthquake also take place. Remember, earthquake also take place here, but volcanoes also take place. Magma, this plate will melt, comes out as magma. When the rock melts, correct, you notice this, rock melts, they become magma. The newly formed magma are called as pluton. The magma that is formed from melting of plate is called as pluton. Pluton. Pluton is a magma formed due to the melting of tectonic plates. Tectonic plates जब melt होगा, जब form होगा ना magma, it is called as pluton. Pluton. Remember, the word has nothing to do with Pluto. Don't confuse with Pluto. Okay, because students have that link. Oh, they'll link it with something else. So I am clarifying it. Pluton means a magma formed due to the melting of tectonic plates that comes out, causing volcanoes. Done. Now see the atlas. Go to North America, South America map. First see North America. Here North America and this is South America. I am writing them together. You notice this. North America and South America, both of them are moving westwards. Here is a plate called Nazca plate here. Nazca. Yesterday we saw Nazca, remember? Nazca. Okay, Nazca plate. Nazca plate is going like this. Okay, Nazca and South America. Here it is Cocos plate. Oceanic plate again. Here is Pacific plate. All of you remember? हाँ देखो Pacific plate, Cocos plate, arrow mark देखो, arrow mark. Notice this, when the continental plate, North America and South America come westwards, they are colliding with Pacific, Cocos and Nazca. These three are oceanic plate. Pacific plate is what type of plate? Oceanic. Cocos is oceanic. Nazca is oceanic. So oceanic continental convergence we are discussing. So what happens here, across this there is mountains formed here. Rockies bolte hain. Dekho Rockies, locate Rockies in your atlas. Rocky mountains. That's what you see. Rocky mountains. Now all of you got to know how these mountains were formed. Why in the western margin of North America? Because of collision. Accretion occurred and all the sediments were folded here. These Rocky mountains. From where? See here, from here, Alaska, Canada, USA, Mexico to Central America tak. Continuous mountains hai, continuous. Okay, so that means this side there should be trench and islands होना चाहिए. हाँ देखो यहाँ पे देखो trench है, यहाँ पे Aleutian trench, here trench है यहाँ पे, Guatemala trench here, series पूरा trench है यहाँ पे, Aleutian trench. This I'll show you in the other map. Here Guatemala trench or Central American trench, Middle American trench. Locate trench ऊपर से लेके नीचे तक. हाँ, so this one trench, ये रहा trench, Guatemala, Aleutian trench. See, ये रहा atlas, this atlas में दिया है देखो, Aleutian trench, Guatemala. हाँ, you're able to locate this trench. This is Aleutian trench, Aleutian Islands के नीचे, Alaska, Aleutian Islands. This is the Aleutian Islands. This is a trench, blue color, and this is another trench here, Guatemala. Show her also. All of you got it? Please ask me now only if you are unable to locate. I'll come. I'll come. Wait. See, wherever we need the concept, I'll dictate. Correct? And diagram I'm writing, every information I'm writing. Okay. If I start dictating, what happens? It will go to 200 hours of class. That is the reason we are giving you material, printed material we are providing you. Okay, plus class notes, plus NCRT, plus that book I told you, just Parados. So read all this. You have multiple sources. Then after some time you will say, sir, so many books, where to read, what to read, and that. Too much material also, it will drive you mad. You got it? My class notes, this one. Everything you are writing, plus NCRT, class 11th, plus GC Leong bhi hai, so along with that. Then just Parados book, plus our classroom, this one, printed material. So same concept you are reading in 4 different places. Okay. So there is an understand this, because these are all, so many facts are there. Imagine I have to dictate means I have to mention Pacific plate, Cocos plate, Nazca plate colliding with South America, Central America, North America, like that. It will become too many facts. If you read, it will become confusing. Okay. So just remember the concept. What is this concept? Oceanic continental. देखो क्या हुआ यहाँ पे है पूरा. Oceanic plate subducts. That you know, trench is formed. The other side, continental plate will fold. That results in formation of mountains, fold mountains with volcanoes. That is the reason Rockies have so many volcanoes. यहाँ पे बहुत सारे volcanoes है इसलिए. Okay, Saint Helens, Rainier, all these volcanoes है बहुत सारे ऐसा. देखो triangular और volcano है. पूरा volcano. Okay, Rockies. Next, go to South America map. यार देखो यहाँ पे Andes mountain रहेगा. Andes are again fold mountains. Cordillera of the Andes लिखा होगा. Cordillera. Remember yesterday Cordillera I told you NCRT class. What is Cordillera? Parallel mountains are called as Cordillera. हाँ देखो Cordillera is this. Andes. This is Rockies. Andes and Rockies. So mountains on one side, accretion on one side, this side, mountains. On the other side, trench dundo, Peru trench, Chile trench. Because of the country called Peru and Chile. There is one country called Peru. Uske baaju mein Peru trench. Another country called Chile. Next to that is Chile trench. See the political map. This side political map bhi hai. If you have doubt of the countries, you check which country is where. Peru, Chile. Trench also is called as Peru trench. 6,000. Chile, 8,000. Don't remember the depth. UPSC will not ask numerical facts. Numbers नहीं पूछेंगे. सिर्फ concept. Are you all able to see? Those who don't have atlas now has to share. You only arrange when you come to the class. If you have don't have atlas, sit with someone at least who have atlas. Okay. Done. The Pacific plate is colliding with North American and South American. Done. We have trenches and mountains. Trench, mountains. Okay. This is one side. The Pacific plate is also moving northwards like this. North and westwards like this. Pacific is the largest plate. Remember I told you yesterday? Which is the largest plate? Pacific plate. So Pacific plate is going in like this. Northward direction like this. Okay. It is colliding with Eurasia also this side. This is equator. Please notice this is Russia here. I am writing Russia now. Korea, China, this side. This is India here. Indonesia here. See here now. The Pacific plate is colliding with Eurasian plate also. This is Eurasian plate. Eurasian plate here. This is Indo-Australian plate. Indo-Australian plate. Indo-Australian plate. Please remember the plate names. Like this. Okay, this is which country? Russia here. This is China here. Okay, this is Japan. This is Australia. This is Philippines. India. Okay, this is New Zealand. All of you notice this. So the Pacific plate is also colliding with that side North America, South America. This side Eurasia and Australia. Indo-Australian plate. So across this belt you notice series of islands are formed. You can notice now. This is Kuril, Aleutian, Kuril Trench. Locate Kuril Trench. This is Japan Trench. Japan Trench. Here Mariana Trench. Mariana. See Asia map. Philippine Mindanao Trench. Mindanao Trench. Mindanao Trench. Here Indonesia, Java Trench. Java Trench. Okay. Please notice this is Pacific Ocean I am showing. In the atlas, start from the top corner, this corner, upper, full, Aleutian here. Start from the north corner. In the northeast corner, start from the Aleutian, then Kuril Trench, Japan Trench, Mariana Trench we have already marked. Okay, Mindanao Trench, Philippines. Arrange the trenches of Pacific Ocean from north to south. See the question they are asking. Arrange the trenches of Pacific Ocean from north to south. So many students will not be able to answer. If you have seen this once, at least you will recall exam. Which is Aleutian here, Kuril, Japan, Mariana, Mindanao. At least you should be able to say in order. Then further this side is Java, Indonesia, Java Trench. Okay, Java. After this, you can see here Tonga, Kermendak Trench here. Okay, Kermendak, Tonga. It's not given in the atlas. It's okay. It's not given in this page. It's okay. Please see here. Notice that Pacific plate is the oceanic plate, largest plate. All of you pay attention please, eyes on the board. The Pacific plate is the largest plate and it is colliding with Eurasian plate, Indo-Australian plate here, North American plate, correct? It is converging. Here Nazca is converging with South America. Because of this oceanic continental convergence, across this belt, you notice this, from here, from Chile, across this Andes we have volcanoes. Again North America we have volcanoes here. And here also volcanoes. All this color indicates volcanoes. Japan volcanoes, Philippines volcano, Indonesia volcanoes, here volcanoes. Across the Pacific Ocean, we have 1000 volcanoes as of now. How many? 1000. Okay. Out of which 50 of them are active. You can imagine now. Okay. 70% of the world's volcano occur here in this region. 70% of the world's volcano. 90% of the earthquake. Please pay attention, don't write. 90% of the earthquake occur here. So majority of the earthquake in the world occur where? In this region around the Pacific Ocean. So it's called as Pacific Ring of Fire. This is called as Pacific Ring of Fire. Pacific Ring of Fire. Pacific Ring of Fire. Okay. So nearly 1000 volcanoes में 50 of them are active. 70% of the world's volcano, 90% of the earthquake. Okay. Pacific Ring of Fire starts from let's say Chile here, Chile and up to New Zealand. All of you see here, I am adding extra information. Which country is that? Chile. This is New Zealand. Already I had written, you can notice. You can just write. Can you imagine? I'll tell you one more information. See here, start from here. This Pacific Ring of Fire up to here is 40,000 kilometers in length. Can you imagine? 40,000 kilometers is the length of the Pacific Ring of Fire. Starting from this corner to that corner. And width is 500 kilometers. Width. See my hand? This width is 500 kilometers width. The 500 kilometers width is volcanic width, where you have regular this length, this width. So Pacific Ring of Fire, if they ask you this in the exam, what would be the introduction? The question itself is asking about Pacific Ocean itself here. That is the keyword. You have to first talk about introduction Pacific Ocean. Pacific Ocean is the largest ocean in the world. Correct? It is a remnant of Panthalassa. Correct. Pacific Ocean is surrounded by many continents such as North America, South America, Eurasia and Australia or Oceania. Like this. Introduction mein ye aana chahiye. Whenever you are writing something, you have to elaborate that part first. Introduce the topic to the reader. Then the Pacific plate, being the largest oceanic plate, is denser. It is colliding with other continental plates which are lighter. As a result, the oceanic plate subducts, forming trench. This diagram you have to write. This diagram. In this diagram, we are showing how the trench is formed, how the mountains are formed. This is the base. After showing this, we have to show this. So Pacific plate is colliding with here North America, Eurasia, Indo-Australian plate. Then Nazca is colliding with South America. Because of which we have trenches, series of trenches across the Pacific Ocean and volcanoes and earthquake. So this belt stretches for 40,000 kilometers in length, 500 kilometers in width. Nearly 70% of the world's volcano take place here and 90% of the earthquake. Pay attention. Correct what I am saying. Nearly there are 1000 volcanoes here, out of which 50 of them are presently active. Like this you have to elaborate in the body of the answer. This diagram also will come. In this diagram you can mention all these trenches and all. See how the answer starts. Pacific Ring of Fire, first Pacific Ocean introduction. Then you write this. Okay, since it is surrounding Pacific Ocean, some authors call it as Circum-Pacific Belt also. Circum-Pacific Belt. also. So if the exam they ask you this circum-Pacific belt, don't get scared. Same question को दूसरा नाम से they are asking. That is where UPSC में students are getting scared when they see the paper. See, all have attended classes. You will know the main concept. If they use some other word, you will get scared. That you should avoid. You should know the alternative name also. That comes with reading NCERT, reading books. Okay. So why am I telling you this? Because I know what has happened in the last 10 years. We are getting a lot of lazy students. Okay, don't mind I am telling you this. They want like notes, ready-made notes. If you give them books, they are not reading that. So they say, please give small version. Means they want to shortcut. That is not there. That's what we are trying to tell you. Correct. This exam is about knowledge. That I can't. If I give you few pages, let's say, obviously you are at risk. I can impress you here by giving notes, but it will put you in trouble in the exam. You got it? So I don't want to do that. Correct. Dictating this it will take another half an hour for me. But problem is you will not read books. So that is where you are in trouble. So always read NCERT. And students have stopped reading NCERT. NCERT ka bhi concise version they are buying. In the market there is a book I saw. It is NCERT is concise. From 6 to 12 they have made one book. That is wrong. Because NCERT each and every line is important for the exam. I hope all of you know what I am talking about. So don't do that mistake. UPSC is a very simple exam. Don't make it complicated. And NCERT is like 40 rupees book. And the concise book is they are selling at 300, 400 rupees. So you are wasting time and money there. The students after 2 attempts they realize this. Oh, we should have read the NCERT. And by then it will be too late. So take NCERT, read, mark. So done. This diagram, you know. Pacific Ring of Fire. How it looks, you know. Trenches, you know. Information here, factual information also I have given. Okay, here 1000 volcanoes hai. 1000 volcanoes. 50 of them are active, presently active. Okay, imagine all 1000 of them they go active. You got it? All 1000 volcanoes here. New Zealand has so many volcanoes. Indonesia has volcanoes. Japan, Philippines. Every day there are earthquakes taking place here now. I'll show you. Now only I'll show you. Just give me 1 second. Anyhow, I have to show this. Check your atlas. Keep seeing the atlas. So this is this is last 24 hours. In the last 24 hours, where all the earthquake has occurred, you can see. Okay, notice this please. This is the world map. All of you can notice. Notice this. This is the Pacific Ring of Fire. ये देखो. Last 24 hours में the earthquakes and volcanoes that have occurred. You got it? I am not showing some old data. I am showing date also. You see, here it will come. So active volcanoes and recent earthquake worldwide. There they are showing. See, Saturday, July. Correct? They are showing. Okay. Can you see this? You will be shocked. The place what we are all seeing now. Aleutian देखो यहाँ पे. Kuril देखो यहाँ पे. Japan. See. ऐसे volcano. I'll click on the volcano. देखो. See. Tornado volcano. Unrest. Caldera. Recently erupted. Last update. They are showing. Correct. Like this it is erupting. Since then it is erupting. It has become active on the. Since 2024 it has become active. Like this. You can notice this are all. This is Mariana. This is Mariana region. Here. Okay. Ogasava and this is all near Mariana Trench region. See Philippines. Indonesia देखो. We are close to it. See. This is Barren Island. Okay. Barren Island. And then here. This Indonesia देखो. Series of, as if somebody has kept a Deepavali flower pot. Correct? And they are like igniting it. It looks like that. So we are all in kind of a danger. Because these volcanoes what they give. Now only 50. If you count 50 of them are active. If all thousand go active, it's like a global Diwali, we call it as. Correct. The volcanic ash, dust, smoke release will cover our atmosphere. For many days, we'll not be able to see sunlight. We'll not be able to see moon for many days together. When the sunlight won't reach us, the Earth's surface, whatever sunlight is falling on the dust will go outside, reflected back. Earth's surface will not receive sunlight. If 2 days sunlight won't reach us, all plants will die. Correct. That's the end. All crop loss. Herbivores will die. Then carnivores will die. Then us, finally. Thus, because of smoke and ash only, we will inhale that smoke, ash, dust. We'll choke and die. We'll not have clean air to breathe. So, Earth temperature goes down. Because sun is the source of energy for Earth's surface. When sun energy is not there, heat goes down. So, temperature of the Earth starts going. Water starts freezing. It will go sub-zero temperature. Rivers, lakes and all will freeze. Got it? This is called as global cooling. From we are global warming, suddenly Earth volcanoes can push us into global cooling phase. You got it? So that's how planet regulates its temperature. Our planet has a capacity, correct, to regulate the temperature by erupting all the volcanoes at once. Okay, from global warming, suddenly we'll be all pushed into global cooling. So most of the species will go extinct. We also will go extinct because of that. So Earth can regulate its own climate. That's what I'm trying to say. So they'll ask global cooling in exam. What I just told you now, the story, they'll ask you in the exam. Because everybody is talking about global warming. Nobody is thinking about the opposite of it, which can be triggered by global volcanic eruption. So that is the reason I'm telling you, Pacific Ring of Fire में जो volcanoes है, these are very dangerous. These ones, if they all go active, it will cause lot of problem for Earth. Life as we know will go, okay, extinct. Some species will survive. I'm saying majority species is what humans will all go extinct because of this. So that is then we have to appreciate what we have. See, there are earthquake in India also. Where? 4 magnitude earthquake. Dekho. 11th Calcutta time zone. What is this here? Karkhoda. 16 hours ago. Means Haryana, north of Delhi. Haryana Delhi border. Okay. Means every earthquake, every volcano, we are maintaining a database. This is a website, earthquakes.volcanodiscovery.com. They are maintaining database every day database. Okay. Remember yesterday I was telling you Italy and all here. Correct. Mediterranean Sea. Dekho. Lot of volcanoes here. See Mount Stromboli, Vulcan. We'll discuss this, don't worry. Okay. So Pacific Ring of Fire, all of you know now. So in conclusion, you can write. So there are nearly 1,000 volcanoes, out of which 50 are active. If all these volcanoes can go, if they go active, it can result in global cooling. Global cooling. So like that, in conclusion, we can talk about that. When I say continental, I am talking about Indian plate colliding with Eurasia. Our own case here. Example. Continental is Indian plate colliding with Eurasian. Other example, Africa colliding with Eurasia. Two cases will take. Continental case. See, we all know Indian plate was with Gondwana earlier. Correct. Many years ago. Correct. India was where? Part of Gondwana land. Gondwana land. So, can I write that now? So, the case, all of you got to know which are the two examples I am going to discuss. First, I am taking this. Second, I am going to discuss this. Both are continental plates here. As a result, remember, between Gondwana and Laurasia, we had a sea called Tethys Sea. Tethys Sea was the sea between Laurasia and Gondwana. All of you know, Laurasia here, Gondwana here. Laurasia, Gondwana. In the middle was a sea called Tethys Sea. Tethys Sea. Tethys Sea. And this was surrounded by Panthalassa. Correct. Laurasia consisted of North America, Europe, Asia. Gondwana consisted of South America, Africa, Madagascar, India, Australia, Antarctica and all. This is Gondwana. Okay, please remember this. Tethys Sea was a geosyncline. All of you pay attention. This is Tethys Sea look like this. This is Laurasia. This is Gondwana. In the middle is a depression, right? That is the sea here. Tethys Sea. That means from surrounding side the river water will flow, rain water will flow. They will bring sediments, river water. All the sediments will be here. Correct. The sediments. These are sediments. It will have lot of sediments. What happened? It's not working? You're turning it off. Turning on. Okay. Why are they not turning it on? We need one more AC there, I think. Wait. Okay. Any doubt? What is wrong? What's wrong? You are writing something, she is writing something. What is happening? Don't do that. Pay attention. So, what is this? Laurasia, Gondwana. In the middle is the Tethys Sea. Tethys Sea is the geosyncline. See, this is a depression. Geo, sink, depression. Like the depression. Geosyncline. Geosynclines are characterized by sedimentation like this. Shallow water sedimentation. Shallow water depression. Shallow water means like this. Water is here. Below that is sediments. Lot of sediments are there. Okay. Now among this, you can notice that India was here, Gondwana, and started moving towards Laurasia. Please notice this. This is Madagascar, this is India, South America, this is Africa, Madagascar, India, Australia was here, Antarctica was here. Okay, this is how Gondwana used to look like. It was all in the temperate and polar region, southern hemisphere. Okay, so we had a lot of ice here surrounding this. Okay, this is equator. Equator, 0 degree. So around 120 million years ago, somewhere around 120 million years ago, India got separated from Africa, Antarctica here and Australia. It got separated from rest of the surrounding continents here, Australia, Antarctica and Africa. How many years ago? 120. So it became like this. See, India was like this. Like this. This is Madagascar. What you are seeing is Madagascar here. This is Madagascar. This is India. Around 88 million years ago, India went up, Madagascar remained like this here. Okay. So India and Madagascar got separated somewhere around 88. Then India was surrounded by water. So it was called as Jambu Dvipa. Jambu Dvip. Jambu means what? Elephant size. Big ganta. Dvip means surrounded by water, island. So India was an island actually in southern hemisphere, part of Gondwana. Okay, so it was in different climate earlier. So slowly India started drifting in north-northeast direction like this. North-northeast direction. Around 50 million years ago, it crossed equator. Around 50 million years ago, Indian plate crossed equator from southern hemisphere to northern hemisphere. So now you see, India is coming from some other climate to some other climate here. It was in temperate climate, polar climate. Now it is coming to tropics. Here we have Eurasia. Eurasian plate we have. Eurasian plate here. So Indian plate came and collided with Eurasian. In the middle was Tethys Sea. Here. So what happens? Tethys Sea contains a lot of sediments. It was a depression, geosyncline. All the sediments got compressed. When all the sediments get compressed, what happens? They get squeezed and they'll be lifted up, forming the Himalayas. Water went sideways like this. All the water started separating. The Indian plate collided with Eurasian plate. I'll show you that now. Now you notice Indian plate is where? It is now here. No, here. See the arrow mark like this. So the Tethys got closed because of the Indian plate. The Tethys got closed here. This is how it looks now. See how it was here. I'm showing you the sequence. Slowly it is moving upwards. So this diagram helps you to understand where was India earlier and where it is now. Now when Indian plate came here, it came to tropical climate. Now the desert was formed. Rajasthan became desert now. Earlier it was not a desert. When India was here, Rajasthan was under a swamp, a large swamp, underwater, lot of trees were there. Okay, so it was part of this region and also part of ice. Southern part was under ice in India, this region. India was in temperate and polar. When India came here, then all that ice melted. One. Plus, the Rajasthan became desert because of a new climate it is in. Please remember, that is the reason Rajasthan has a lot of oil. If you explore Rajasthan, we have got oil there. We have got coal, very good quality coal we have. That explains that Rajasthan was not a desert earlier. Even Sahara was not there earlier. Africa didn't have Sahara desert earlier. When Africa came here, then the Sahara was formed. Please remember this. Okay. So when Indian plate started moving or drifting in northeast direction, can I use the word northeast like this? Northeast direction, collided with Eurasia. So all the Tethys sediments were compressed here, and the Himalayas were formed. This is Himalayas. Himalayas. This is Tibet. Because of the sediments got compressed and uplifted. These sediments. That explains why we have marine sediments in Himalayas. We get marine fossil, starfish fossil milta hai. We get limestone there in Himalayas. How is that possible? These are formed normally in the ocean, underwater. We got whale bone also. Whale bone in Himalayas. Means what? All this was here earlier. When all the sediments went up, they got compressed, they were lifted up. So we have marine sediments where? In Himalayas. Okay. So one of the climber recently, at the height of 4,500 meters in Nepal, he was like hiking up the mountain. So the rock showed some fossil. So he took that fossil. After examining that fossil, we came to know it's a starfish fossil. At the height of 4,500 meters. Normally, starfish is found on the ocean floor. Here. How did it go up? Did it also started climbing Mount Everest? No. It was here. Correct. When it got compressed, all the sediments went up. So as a result, Himalayas have what sediments? Marine sediments. So please remember this. So this is one part, one top view. Here I am writing what is side view. Let's say Indian plate is here. All of you notice India. This is Eurasian plate. In between was Tethys, correct? This is Tethys. Indian plate is continental. Eurasian plate is also continental. But Tethys plate is oceanic. Tethys is oceanic. Oceanic plate. Like this. Like the sediments, see. All these sediments. So the Indian plate is moving in this direction. Eurasian plate is stationary. It is there only. When Indian plate started moving like this, Tethys plate was pushed towards Eurasian. That you can't see that here. I am showing you there. When Indian plate started moving northwards, northeast direction, the Tethys plate was also pushed in the same direction. During this, what happened? The Tethys plate is oceanic. Eurasian plate is continental. Remember, this is oceanic plate. Now what happens? You notice. Notice Indian plate has come here. The oceanic plate will subduct under the Eurasian plate. Here we can see mountains started forming, islands and mountains. So initially it was oceanic continental convergence. Oceanic continental. We can notice this. So in the Eurasian plate, a lot of mountains were formed here initially. See, this is the water trench. Initially there was a trench also here. Okay, then what happened? Indian plate further pushed this Tethys plate under the Eurasian plate. Notice that Tethys plate subducting under the Eurasian. Okay, please notice this case because it is a oceanic plate, denser plate going down under the Eurasian. In the next case, you will notice here the Indian plate is like this. This is Eurasian plate here, Indian plate here. Please notice this. The Tethys plate is completely gone now. It is completely destroyed here. What happened to the sediments that was here? They were folded up. This is Himalayas, like this. Like this. Like this happened. Now it is continental now. Both Eurasian and Indian plate are continental. So no more subduction. So it has stopped. Now it has stopped. So these mountains you can notice now. The Himalayan mountains here. Okay, this is Himalayas, this side. This is China, Kunlun Shan. This is Tibet in the middle. Check Asia map. You're in Asia only. See that now. North of India, you notice all of you. This is how it has happened now. Asia physical. Notice north of India. First locate Himalayas. Then Tibet to the north. North of Himalayas, Tibetan plateau. North of that is Kunlun Shan. Look at that. Kunlun Shan. Kunlun Shan. All of you got it? So this is how it looks. Now you notice this, please, all of you. You might say, sir, what happened to this? This completely got destroyed, Allah. Because it's going down. Denser plate got subducted. Tethys plate got destroyed. Tethys plate got destroyed. What happens when it gets destroyed? Like magma is formed. The magma comes out, correct, forming small pockets of magma chamber here. Small magma chamber is still present. So notice this now. This magma heat will come up slowly. All of you pay attention, please. Very interesting thing I am saying. The heat from the magma is slowly coming up here in many spots. Many spots it will come up. Okay. When the heat from the magma comes up, notice this here. Let's say these are mountains and all. Rocks here. Our rocks contain groundwater. Our rocks contain groundwater. So when the heat comes up, what happens? When the heat comes to the surface, the water heats up. The water starts heating up. Correct. Surrounding rocks are hot. That hot water comes out. Hot spring. That's how hot springs are formed. Now you know, okay, how hot springs are there. Many hot springs in Himalayas. That explains why we have many hot springs like Manikaran, Parvati Valley, Himachal Pradesh, Puga Valley, Ladakh, Chumatang. All these are like this. The Tethys plate which got destroyed, correct, magma pockets are here. These are magma pockets, small chambers of magma. Slowly the magma heat comes up because that is how it is cooling. Magma chamber is cooling. During that cooling process, the heat comes up, heats the rock and then the water, causing, yes, hot springs. Sometimes the water becomes very hot, steam comes out like this. Then the steam also comes out when the temperature is very high. Then it's called as geyser. Geyser. We have many hot springs and geyser. Steam is released. That is geyser. Okay. If hot water comes out, spring. If this water comes in the form of steam, geyser. Okay. So remember, that is the reason we have hot springs and geyser. All of you got it? What happened? What happens if this is melting continuously? Then more magma would have been supplied. More magma means more volcano. That is not happening. Only Tethys plate was there that got destroyed. So no more subduction. So no more volcanoes. That means initially when the Himalayas were forming, during this case, this was melting and there were some volcanoes initially. Initially there were volcanoes during the formation of Himalayas. All this can be seen in Tibet now. In the Tibet region and China, Kunlun Shan, I showed you. There are 70 volcanoes there, extinct volcanoes now. Kunlun Shan has around 70 extinct cones, which are earlier active. So on the Chinese side, there was a lot of volcanic activity during the initial stages of Himalaya formation. Once Tethys plate got completely destroyed, it is only continental plate now. Because we all know continental plates have almost same density, so subduction doesn't take place much. If this one of the plate was denser, subduction would have continued. So the volcanoes also would have continued. Since both of them are continental plate, subduction has stopped. See, both the plates are continental plate. Now you know why Himalayas don't have volcanoes now, but only earthquakes. Because Indian plate is still moving northwards, compression is still taking place here. That compression causes vibration, earthquake across. So you have to write this diagram first, then that. This is A, this is B, this is C. Okay. See, in this last case, I am not showing any Tethys plate here, because Tethys plate is completely gone. Only some pockets of magma chamber. Red dot indicates magma chamber. Magma chamber. This color indicates the heat rising. Heat. Okay. Also called as geothermal energy. Geothermal. All of you heard of the word geothermal? What is geo? Earth. Thermal, heat. Geothermal. Start from here. Very interesting topic. Now you know how Himalayas were formed. This topic can become a question. Discuss the formation of Himalayas with a suitable diagram. Then first you have to say this. If you are not writing this diagram also, chalega. But that is important. Those diagrams are important. This one you can just elaborate. Geologically, India belongs to Gondwana land. 120 million years ago, India got separated from Gondwana. Around 88, it got separated from Madagascar. Then it drifted in northeast direction towards Eurasia. Okay. Then it collided with Eurasian plate. Now India is where? India is northern hemisphere, part of Asia. Today India has become part of Asia. Notice the shape of India, rhombus, almost like a shape of a rhombus. Can I go to the next page? Right. Let them all right. So, if you have a doubt, ask me now only. Why is Tethys plate subducting? Because it is oceanic. Why is Indian plate not subducting? Because it is also continental. Density is very important. Sri Lanka is part of Indian plate. Sri Lanka and Pakistan, Nepal, Bhutan, Bangladesh, they are all part of Indian plate. Can I go to the next page? Complete this. Now the scientists are saying that Indian plate is slightly denser than the Eurasian. So it is slightly going under Eurasian. Not subducting, but slightly like this. See how it is locked? Both the plates are locked. Just like when you lock your hand like this. Indian plate is in a tectonic lock with the Eurasian plate. We call it as a suture zone. Suture, where they have stitched like this. Suture. Okay. This explains why Himalayas experience earthquake but not volcano, because they are in the final stages of tectonic movement. That means now the volcano has already ceased. Finally, what will happen? The magma chambers also will cool, solidify. Hot springs will stop. Geysers will stop in next few years, million years. After that, the Indian plate movement also will stop. Okay, Himalayas will not grow further. As of now, Himalayas are slowly increasing. That is the reason they are called as young fold mountains. Himalayas are called as what fold mountains? Young, because they are forming now. So that is the reason you can see the highest peak. Whenever the mountains are like growing, their young stage, you can see the highest peak. After that, what happens? Weathering, erosion will become more common. The height will start decreasing. Correct. In our lifetime, we are seeing the highest peaks. Okay. So remember this. One more diagram is there. I'll write after this. Hot springs and geysers are formed when the geothermal energy comes in contact with the hot rock. In turn, it comes in contact with water, groundwater. You got it? Hot springs and geysers, I'll only write. Hot springs and geysers are formed when geothermal energy, all of you understand geothermal energy. Don't write geothermal heat energy, because thermal means heat. Geothermal energy comes in contact with hot rocks, which in turn comes in contact with groundwater. Simple, correct? Agree? Very simple words. So what happens? The groundwater heats up, comes out on the surface, forming hot spring. Sometimes the temperature goes up to 100. Then steam is formed. Steam comes out. Just like a pressure cooker. Pressure cooker ka steam kaisa aayega? After certain pressure is reached. So it gushes out, releasing that pressure from the earth's interior. That is geyser. Okay. Geyser is like a stream of water. Steam. High temperature water. So if you go to Himachal Pradesh, Ladakh and all, lot of hot springs are there. Okay. I'll tell you one more interesting thing here. So the geothermal energy comes in contact with rocks. So rocks heat up. Okay, listen to this now. When the rocks heat up, certain minerals leach. Like say means they'll come in contact with water. So some minerals like sulfur and all comes in contact with water. That water comes out, sulfur also comes out. Some minerals come out with water, I'm saying. When the rocks heat up, they leach certain minerals into the water. That water comes to the surface, bringing those minerals to the surface. That means if I go and take bath in that water, it is very good for the skin. The hot spring water has some lot of benefits to the skin elements and all. So that is when people with skin diseases and all, they go and jump into that hot spring. Geyser. That will cure them of many diseases. That is the reason many hot springs have become resorts now. Hot spring resort. In India it is not common. In Iceland I have been to many. In Iceland there are many hot spring resorts. where there is every hotels have a hot spring pool connected. So it's like a hot water pool. It's very nice because outside temperature will be very less. So swimming in that is like kind of different experience. So I've seen that in Iceland. I've done that. So Japan also we have nowadays, very expensive. Japan is very expensive. The Iceland is free here. So every guest will have access to that hot spring spa. Okay. So remember this. Okay. How the Himalayas were found, all of you know now. So why no volcanoes now? Because the Tethys has completely subducted. No more Tethys plate. So since Indian plate is still moving northward, that is causing vibrations, which is resulting in regular earthquakes. So we have Himalayan countries, Himalayan states. Which are Himalayan state? Jammu Kashmir, it is here. Ladakh, it is here. Nepal is here. Bhutan is here. So when the earthquake occur, all this will shiver Allah. So that is the reason all of them are affected. We are building homes where? On mountains. Obviously we will suffer. Landslide hoga. So as a result, all this can be triggered because of the earthquake. Okay. That is the reason we say Himalayas have very fragile ecosystem. Very fragile ecosystem. Landslides are very common. And these mountains receive very heavy rain. So as a result, you know what is happening in Himachal, Uttarakhand now? Heavy rain ki wajah se there is a lot of waterlogging everywhere. And also lot of flood situation in Himachal and Uttarakhand because of this. So this is clear. See Asia map now. Let's draw that quickly. I am drawing India first here. India. See, this is Pamir. Pamir. Look at Pamir. North of India. Same map. Same map. Asia map. North of India. Here, physical map. Pamir. This side, Hindu Kush. Hindu Kush. This side, Karakoram, Ladakh, Jaskar, Greater Himalayas. Himalayas. This Shivaliks. See, I am marking Himalayas here. Locate Kailash. Locate Mount Kailash. Himalayas, Kailash. No writing, only you have to see the atlas first. Kulun Shan. Tain Shan. Okay, see here. This is all Himalayas now. This is Tibet. Tibet. Tibet is a plateau. Tibetan plateau. Start from the Himalayas, go up to Tain Shan, China. Here is Kirtar Suleiman range. Kirtar Suleiman in Pakistan. Here. This is all Indian plate boundary. This is all Indian plate boundary. Indian plate is up to here. Kirtar Suleiman. Hindu Kush. Hindu Kush. Pamir. Okay. Kulun Tain Shan. Tibet. Himalayas. Notice the boundary of Indian plate. According to the boundary of the Indian plate, the mountains are folded. What was the shape of Indian plate? I told you shape was like this. Correct na? I told you Indian plate was like this, rhombus shaped. Along the boundary only the mountains are folded. That is the reason you can see here it's Burma side here, Burma plate. Indian plate is colliding with Burma plate. Remember yesterday I told you Burma plate? This is Eurasian plate here. Eurasian plate. This is Indian plate here. This is Persian plate here. Persian. Notice this please, all of you. India is surrounded by many plates. Eurasian in the north, Persian plate this side, Burma this side. When Indian plate collided with all these three, the mountains were formed along the edges. So that is the reason the mountains look like this. All this was one country earlier. Forget the border for a while. Okay. It was like this earlier. Before partition. Correct? All this is the Indian plate. Okay. Along the boundary. Starting from Pakistan-Afghanistan border. All the way up to Burma. Okay. Okay. So now you notice here how Himalayas look like. Kulnshan, Tanshan, Pamir. Now, here the mountains are turning here. You notice this. Here also mountains are turning like this. Notice these two corner. Why? Because the Indian plate boundary collides with the Burma here. Indian plate collides with the Burma plate. Along the boundary, the mountains are formed. I just told you now. That is the reason here, since this is the boundary, the sediments turn like the mountains turn like this along the boundary of Indian plate with Burma plate. So this kind of bend is called as syntaxial bend. Right? Syntaxial bend बोलते हैं इसको. Syntaxial bend. यहाँ पे भी है. This is also syntaxial bend. This is western syntaxial bend. Eastern syntaxial bend. Western and eastern syntaxial bend. So along the boundary of the Indian plate, the sediments are folded, mountains are formed. So the mountains are also appear to have bent on the edges. Okay. I'll write that theory here. Along the boundary of the Indian plate, mountains are formed. As a result, we have syntaxial bends, eastern and western. I'll wait for you all to write. Who turned on? Syntaxial bend looks like an elbow. In simple English, elbow. Like, okay. Imagine somebody standing like this with their hand on the hip. Like this. This is the elbow. Elbow bend. Ye wala. Okay. Syntaxial. So this bend causes the mountains to bend along the boundary of the plate. I'll tell you why it is important now. So Pamir and Tibet are called as roof of the world. Roof. RWF, roof. Means like upper part of the building is called as what? Roof. Roof of the world. Because they are the highest plateau. 4,000 meter, 4,500 meter is the height of what? Pamir and Tibet. They are called as third pole. North pole is Arctic. South pole is Antarctic. Third pole is this. Because they receive very high snowfall. Very high snowfall where? Here. Pamir and Tibet. So the third highest snowfall takes place in Pamir and Tibet, Himalayas. So the word Hima means snow. Alaya means home of snow. Okay, what is Himalaya means? Hima means snow. Alaya means home of snow. Shall I continue? Done? Clear to all? Notice this please now. This is one syntaxial bend, this is one syntaxial bend here, where the rocks turn down, mountains turn down. Notice this here. This is Mount Kailash. Mount Kailash is a source of Indus River. Okay, it takes birth here. Mount Kailash mein Indus River takes birth here. All of you, all eyes on the board. The river takes birth here and flows like this between Ladakh and Jaskar range. This is Ladakh, Jaskar. Flows here. As it comes here, we get mountains. I told you, rocks are bent like this. So river turns here south and flows into Arabian Sea. All of you got it? Why the river flowing westwards like this through the mountains suddenly turns south? Because of the Hindu Kush. This is syntactical bend. Rocks are aligned like this. So river turns it according to the slope. Rivers always follow slope. Slope of the rocks. Slope of the land. Got it, all of you? That is the reason Indus flows like this, then turns south. You notice, check Indus. See Indus now. Some extent it goes like this. Correct. Suddenly it turns southward. I have written the mountain name also. Ladakh and Jaskar. Ladakh range, Jaskar. Okay, are the ranges. In between the river flows. In between these two ranges, river flows. And Leh. Leh is the capital of Ladakh. Located on which river? Indus. Indus. Okay. One more interesting river I'll talk about. There is a glacier here in the Kailash, Mount Kailash, Anshi Glacier Bolke. Okay. Don't worry, I'll tell you again, all this will come again in Indian geography. Here, notice this. Anshi Glacier se ek river aa raha hai, dekho. This river. Like this. Flows almost parallel to the mountains here. These rivers flow parallel to mountains. This is called as Sangpo River. Sangpo River. All of you notice please. This river flows parallel to the mountains till here. Where the rocks turn south, the river also enters India now. Bihang. And this becomes Brahmaputra. Brahmaputra here. Clear to all? Brahmaputra. Why Brahmaputra turns into India? This is the reason. Because of the syntactical bend. Rocks bend. Okay. Here there is a mountain called Namche Barwa. If you see your atlas. Namche Barwa. There it turns south. Towards India. It becomes Brahmaputra in India. Now notice both the rivers. Indus, Sangpo. They are flowing parallel to the mountain. Then turn south. Exactly where these two rivers flow, that is where Indian plate is connected to Eurasian plate like this. So Indus, Sangpo, suture zone. What is suture? Stitch. Just like my hand. Suture. Indus, Sangpo, suture zone. Spelling I am writing. Suture. I is Indus. Yes, spelling Indus I'll write. Sangpo here. Sangpo. Suture zone. Indus Sangpo suture zone. They'll ask, what is ITSZ? It is a zone where Indian plate is connected to Eurasian plate, where the two rivers flow in opposite directions. Where the two rivers flow in opposite direction. So this entire Tibet and Himalayas were formed because of the Indian plate. That means we can claim up to there. China can't do anything. If they go by the geology, we can claim up to here. Which part? Up to here. North. Because all that was formed because of the Indian plate only. Correct? That is the reason they are using cultural reasons to occupy our territory. They are saying there we have a Buddhist monastery, that, this and all. But that also part of our culture only. Indirectly if you take that. Okay. Geologically, India extends up to there. Technically we can claim up to Kunlun Shan. Okay. Done. So we have covered Indian plate collision with Eurasian plate. Himalaya formation I have covered now only. Correct. So as a result, when I do Indian geography, I will start with this directly. Now you should know where is Himalayas and all. Fold mountains. Okay, please remember Himalayas are young fold mountains. formed due to tectonic collision of Indian plate with Eurasian plate. Okay, Himalayas are part of many countries of Asia. Himalayas are part of many countries of Asia, such as India, Nepal, Bhutan, Myanmar, China, Pakistan, Afghanistan. Okay, like this. Introduction. Himalayas are young fold mountains. Okay, please remember. They are formed due to tectonic collision of Indian plate with Eurasian plate. Simple. Next, see Africa, Europe. Africa moving northward. All of you remember this diagram I have given. This diagram there. Africa is also moving towards Eurasia. Okay. Instead of India, we have to write Africa. That is the difference. Now, I ke badle mein Africa. A here. So what happens when the African plate is moving northward? You notice now. Go to the separate map, please. Europe map. All of you see Europe map. Notice this in the Europe map, page number 80. All of you see here, see my atlas once again. Page number 80. This is Europe. This is Africa here below. Africa is moving northwards. Correct. Africa is moving northwards. So what happened to the Tethys Sea here? Got trapped. The remnant of Tethys Sea is Mediterranean Sea. Notice that. The remnant of Tethys Sea is Mediterranean. Below is Africa here. Africa is slowly moving north. Okay. As a result, you can see the mountains formed here in the southern Europe. In southern Europe, you can see. This is called a South European tectonic zone. This we are seeing here. आप ये देख रहे हो. ये Mediterranean Sea है. Okay. This is the South European mountains. All this. That explains so many earthquakes here. Volcanoes in Italy. Why there are so many volcanoes here? This is the reason. Okay, Africa movement is slower than Indian plate movement. Okay, now notice this from here. This side you notice. From the western side up to here. I'll mention one by one. Okay, South European tectonic zone. This is where African plate colliding with Eurasian. Start from the left. Cantabrian Mountains. Cantabrian Mountains. Cantabrian Mountains. Give me 1 second. I'm here. This is Africa here. Africa is moving northwards. So you see the mountains here. This is Mediterranean Sea. Former Tethys Sea. Correct. Mediterranean Sea. Remember this. So notice the mountains here. Cantabrian Mountains here. I'll use red color. Okay, all of you can easily. Cantabrian, Sierra Morena, Sierra Nevada, Central Cordilleras. Cordillera means you understand now. Parallel. Pyrenees. Locate Pyrenees. देखो, I have marked. That is reason Europe has a lot of rugged terrain, mountains everywhere. Cantabrian, Sierra Morena, Sierra Nevada, Central Cordilleras. I'm in Spain, Portugal now. This is Spain, Portugal. This is Spain. Pyrenees, France, towards France now. Done. Here, Alps. Notice Alps. Alps mountain. All of you might have heard of Switzerland. France, Germany, Switzerland, Italy. Correct. Austria, all this. Then Dinaric Alps. Dinaric Alps. Balkan mountains. I'm marking Balkan mountains. Pindus mountains. Pindus. Balkans. Okay. Here. Alps. Then locate here. Transylvanian Alps, Carpathians, Bohemian Massif. I am here. Carpathians, Bohemian Massif, Transylvanian Alps. Correct? Notice this. Then Black Sea. Black Sea. Black Sea के इस तरफ Caucasus. 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 Okay, here Pontine, Taurus. I think it's not given in your atlas. Pontine, North. Here, this one. Taurus. Turkey. Turkey. Turkey, I think they have not given. It's okay. Caucasus tak diya na. That's it. All these are mountains formed due to African plate moving northwards. Means the Mediterranean Sea is still there. That is sea part of it is still there. But in future it will get closed. The mountains will come here. New mountains will form. That is the reason you see islands are now formed here. Notice these islands. Volcanic. All these are volcanic. Corsica, Sardinia, Sicily. Notice this. Islands they call. Islands start from here. Balearic Islands. Balearic Islands. Sardinia, Corsica. Sardinia, Corsica. Sicily. Sicily. Malta. Malta. Done. Here. Crete. 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 Done. Last. Cyprus. This is where our Prime Minister went. Remember, Prime Minister went to Cyprus a month back here. Last month. Cyprus. Cyprus. Cyprus has a dispute with Turkey. Okay. Cyprus has a dispute with Turkey here. So we have a strong ties with Cyprus now. Cyprus. Okay. Clear? So they'll ask these. These are all what? Now islands are forming. Volcanic islands are formed. These are all volcanic islands. Above. Slowly what happens? They'll go up, grow upwards. All this becomes mountain one day. So this will become highest peak later on in future. So this is a geosyncline. Mediterranean Sea is a geosyncline where the future mountains will be formed. Like this. Okay, wait. All of you got it? I'll go back. Like this. See, now in this stage, future will become like this. Where the Mediterranean Sea will close and mountains are formed. Okay. This explains why there are so many volcanoes in Mediterranean Sea region. So now you should know, okay, where we are. So Indian plate is moving faster, whereas African plate is moving slower. That is then we have mountains, Himalayas. Any doubt? So two cases I have taken. India, Eurasian, Africa, Eurasian. Plate collision. Continental over. Okay. So we started with plate boundary. First one, diverging. We covered. Second one, converging. Last one, right, transform. We'll finish this today. Diverging is called as constructive. Converging is called as destructive. Colliding boundary. Last one is transform. Transform boundary. Transform boundary is not lengthy. We can cover it fast. Here, notice this. Let's say there are two plates here. See here, two tectonic plates next to one another. This one, this one. Okay, let's say they are sliding next to each other. Sliding. Sliding means like this. Let's say two chairs are kept. Two chairs. Let's say one chair goes back, other chair comes front. That is what? Sliding. Sliding boundary. Transform also called as sliding. Sliding. What happens when these two start sliding next to each other? Notice the resultant, please. All of us here. See here now, this plate has gone like this, this has come like this, they are sliding next to each other. Notice this, like this, it has gone this side, this has come this side. Don't you think a lot of earthquakes will occur here along this line? Lot of earthquakes, because both the plates are moving like this, a lot of friction will be there, friction that causes earthquake. No volcanoes, but okay, so no volcano, but only earthquake. I'll write X, earthquake. Earthquakes will occur. Please remember this. Severe earthquakes will occur, dangerous earthquake will occur here, but no volcanoes. Okay, only earthquake. No volcano. Why no volcano? Because land is neither diverging nor converging. In this case, volcano is there. This also volcano is there. Land has to either diverge or converge for the volcano. Here it is neither diverging nor converging. So land is neither destroyed nor created. All of you got it. Here it is. See, diverging mein land was created, crust was created, so constructive. Here the crust was destroyed, so destructive. But here it is neither destroyed nor created. Conservative plate boundary. Now all of you got it. Why it is called as conservation of mass? Conservative plate boundary means conservation of mass. Transform boundary, also called as sliding boundary. First two cases already we have done. Notice in the first case, if you take like this, earthquakes, yes, occur. Volcano, yes, in this. Second case, earthquake also, volcano also. But in third case, yes, earthquakes will occur, but volcanoes, no. Like this. Easy to summarize. Can I clear this diagram? I'll tell you where it happens. All of you see North America map. You can see plate boundary map. This is North America. North American plate, this is Pacific plate, correct? North American plate and Pacific plate, they are converging, correct? Oceanic continental convergence. But in between these two, there is another small plate here. Here. Juan de Fuca. This is going southwards like this. Yes, sir. Between these two are going like this. This is moving down. So Juan de Fuca plate is a small plate. It is having transform boundary with Pacific and North American. You might have heard of a state called California in US. USA में California बोल के एक state है. It is located on this plate only. So very severe earthquake occurs in California. One of the deadliest, most severe here along this boundary. We call it as San Andreas fault. That fault line is called as San Andreas. This is fault I am talking about. ये देखो, this is boundary is called as fault. Fault means a fracture. San Andreas. San Andreas fault. California. This one I can clear. This image. Okay. I'll write the other one here. Last example. So Turkey, all of you know Turkey. This is Turkey. Okay. Turkey is surrounded. Turkey is part of Anatolian plate. Anatolia. Okay. Turkey is part of which plate? Anatolia. Please remember. This side we have Eurasian plate. Eurasian here. This side is African. This side is Arabian plate. Turkey is surrounded by three plates here. This Turkey, north is Eurasian plate is coming like this, Arabian plate is going like this, African plate is coming like this. Tri-junction or triple junction bolte hain, triple junction. Yesterday I was telling you, triple junction is where the three plates meet. Quadruple junction is four plate. So Turkey is a case of triple plate. क्या हो रहा है यहाँ पे देखो, here, this is a fault line here. This is a fault line here. This is called as East Anatolian fault. East Anatolian fault. The recent earthquake in Turkey last 2 years में has happened here along this East Anatolian fault में. Most deadliest earthquakes have occurred here. Okay, in the recent past. One plate is moving like this way, other plate is going like this. Transform plates are shown with two arrow marks, half arrow marks. Transform plate का arrow mark देखो, आधा यहाँ पे, आधा यहाँ पे. Okay, half arrow marks are shown for transform. So one plate is moving like this, other plate is moving like this, causing severe earthquake. Sliding ऐसा. What happens when houses, buildings here, road, railway track, everything will be damaged. The extent of damage, I'll show you the photo now. You'll be shocked. And during the transform case, we have the most dangerous earthquake. They'll ask, among these boundaries, which is the most severest or more deadly earthquake? Transform. Okay, wait for 2 minutes. You see the photo, then you'll understand this. See this image. Try to understand what has happened here. Notice the railway track. Imagine the extent of damage. Normally railway tracks are what we are using carbon steel, and railway tracks are always laid straight. So what has happened here? Up to this is one part, this is another plate here. So this is Anatolian plate. This is another plate. So the plate has moved like this. So see the railway track. That was such a high, iron has a lot of strength. You can't bend like this. The earthquake has done this. Imagine. This is a recent photo. Last year, 2 years में earthquake हुआ ना ये देखो. If the train comes here, what will happen? It will derail here. So the one plate went like this, other plate like this. So the railway track which was laid in the middle got damaged like this. So this normally we have never seen this kind of things. Like you can see lot of here top view. Already accident has already occurred. Can you see this? There is no elevation change नहीं हुआ है, diversion भी नहीं हुआ, crack भी नहीं है, सिर्फ sliding. You got it? That is the reason we are scared of this one. Transform boundaries are the deadliest. But there is another building also there in that line. Half of the building is there, other half is this side. The building has already collapsed, but one half has gone that side and the other half has come this side. Again, that means you can imagine what will happen to the building structures and all. Okay, everything got destroyed. See, New Zealand में हुआ है earthquake. Transform boundary earthquakes are the deadliest. Now you write East Anatolian fault and San Andreas fault. 2 examples I have given. We'll stop now. Monday's class, I'll start with faulting earthquake. Monday. Revise, please revise and come. Okay, in NCERT, you have to read NCERT class 11th. Fundamentals of Physical Geography. and just Pyrodos volume 1. Pyrodos volume 1 में है and volume 2 also. In these two books you'll get what we are doing. These examples, this photo of these places are all mains related. It's given in this book. This NCERT is only for basics. If you have read NCERT by now, you would have understood only basics are covered. Advanced and all, GS mains prelims paper 1, paper 3 is covered in this book. GS 1, GS 3. You will get it in Tiranga and Vikas both. I think Tiranga mein hai, you check. This is ICSE textbook, class 11th, class 12th, ICSE. This is CBSE. All of you Allah, no Allah. NCERTs are CBSE based. This is ICSE based. Okay. Can we stop? Yes. Any answers today? And also we are giving this also, PDF of every class. All of you are getting that? See, whatever I have written, how many pages I have written? 10. We are sharing that. Many students are taking that every day. If you are not taking that, please check with your friends. You got it? Whatever PDF what we are doing here in the class, from the first day I am sharing it. After the class, if you have noticed, I will click this, PDF, scanner will come. You go to your browser, open the lens, Google Lens, scan that, the PDF will come to you. हाँ देखो. Okay. So this is also additional notes for you. Come this side, come this side.